So the objective of this class is to take you through basic data analytics. So there will be primer 1, which is data acquisition and basic data analytics. There are 12 steps we are going to be following, and I've laid them out right here. We're going to be doing it step by step. And in primer 2, we are going to be doing our basic data visualization using a number of tools. So I've also laid them out. You're going to be doing a whole lot of different kind of plots, including I've listed them out here: histogram, univariate plots, density plots, box plots, correlation matrix, scatter plot, peg plot, and you see how this helps you to understand your data. This we are going to be doing in primer 2, but in primer 1 we are going to start from the scratch. We are going to start with acquiring our data, free data set from sklearn. I'm also going to show you how to get free data sets from other sources. We're going to be slicing our data, creating a dictionary using the data set, converting the dictionary to a Pandas data frame, replacing numerical values with target names, writing data to CSV, that is exporting data to CSV so that you'll be able to open it in Microsoft Excel, checking dimension of data set, viewing the data types, getting summary of data, the class distribution, correlation matrix, or correlation between the variables in your data, and checking the skewness of your data, and see how all these terms or all these concepts help you to actually understand your data. So the objective is that if you are ready for data science, then you can decide based on these 2 primers whether you want to move ahead with data science or not. If not, if you want to move ahead with data science, then there is another channel where I'm actually starting data science in 40 days, 5 days from now. So if after this primer you are ready, you can actually join that class, because data science is actually a bit require more analytics way of thinking than normal programming. So let's start now with class 1, basic data acquisition and basic data analysis. So let's start right now. Alright, so the tool we are going to be using, the interesting thing is the tool we need for data science and analytics is only one tool, and that is called Anaconda. Anaconda can be downloaded from Anaconda Downloads. Just search Google, download Anaconda and install it. Once you install Anaconda, it gives you the application called Anaconda Navigator. You can see right here. So once you open Anaconda Navigator, you see this application that has different sub-applications or different applications as part of the ecosystem or as part of the platform. It also comes with a distribution of Python. So we are going to start with Jupyter Notebook, and you can simply click on Launch here. Once you click on Launch, it opens up Jupyter Notebook like you see right here. So it opens up, okay, so it's going to open one more time. So it opens right here. So you see your file system right here. And the first thing I'd like us to do is to create a folder. Again, the step-by-step of what I'm going to be doing in this program is also here in my website. So if you go to Kyneton the Genius, you get to my website, and I'll just show you how to get to where we are. Go to programming and go to data science. I think that should be it. No, so it should be kynetonthegenius.com/data science, kynetonthegenius.com/data science. So you can see where we are right here. I think this should be it. Yeah, so practical data science class for data science beginners. Practical data science class for data science beginners. So these are the 12 things we are going to be doing, and these what we have here in primer 1. Okay. All right. So let's go ahead to get started right now. So the first thing I'm going to be doing now is to go to the home, which is where we are right now. I'm going to just take out this and also take out this as well. So once you go to home, I'd like us to create a folder that says and give the folder a name. So go to new right here and say new folder. So you can see Untitled folder right here. Select the checkbox and say rename. I'm going to just call it primer 1. So that's the name I'm going to call it, primer 1. So if you go to your file system, if I refresh this, I think I should also see primer 1 created. So let's just scroll down. You can see it right here, primer 1. So this is basically your file system right here, right? So it's a normal application that works really well. Again, I have data sets, a set of data I obtained for free from different sources. I'm going to be showing you how to obtain them later on. All right, so we have a new folder called primer1. So to see that folder now, I'm going to go back here. You can see this folder, primer1. So we are going to open this folder and then start working right inside this folder. So I'm going to create a new notebook. I'm going to call this notebook class 1. So once you click on new, choose Python 3 right here and click on the untitled right here. And I'm going to simply call it class 1 because we also have a second class which is about visualization. So this class, it's going to be class 1. This class is about data acquisition and basic data analytics. So we're going to be taking the 11 steps I showed you right here in my website, these 11 steps. In case you miss something, you can actually go back here and check all the steps I'm going to be following in this tutorial. All right, so let's go to the first one. The first one says, I can actually keep this open side by side, but for now, I think I can just leave it closed. So the first one is obtain free data sets. At this point, permit me to just open the two side by side. So let me just go here and keep this side by side with this one. So let's see. Keep this one this way and this one. All right. So this is where we are. Sorry. So I'm going to keep the two open so that you can actually see that what I'm teaching is actually available, and this is actually not something too difficult, although it requires some effort on your part, but it's actually not something too difficult. I'm simply following my own steps I've actually set out on my website. So the first one, run imports sklearn.dataset. sklearn is a module that contains a number of tools you can use, a number of functions, including free data sets. So once you say sklearn.dataset as ds, and then you're going to say Iris. Now, I'm going to load up a data set called Iris. The name of this data set is called Iris. So I'm going to grab it from sklearn and put it in a variable called Iris. So you can change the variable name, maybe Iris data or something. So Iris is equal to ds.load Iris. So what is happening here? Load Iris. So what is happening here is that we are getting free data set from sklearn. So ds is sklearn.dataset. When you say ds.load Iris, it's going to load this free data set onto a variable called Iris. Now, what you want to do is to view your data set. So I can actually say Iris, and it shows me what this data set is all about. So you can see that it tells me we have data, and we have, if I scroll down, I have targets, and I have target names, right? So I have three aspects of this data I want us to take a look at. We have the data, we have the target, and we have the target names. So to separate them, or to kind of view them separately, I'm going to simply say iris.data, and you can see the data part of this data, right? So it's made up of 4 columns here. And if I also say iris.target, it also gives me the array of the targets. And if I now say iris.target names, it gives me target names. I think so. You can see we have about 4 different target names. Now let me go to my whiteboard. Let me just show you how this data, or what this data looks like. So I was working on this data is basically something like this. Let me this is blue pen. So we have call 1, call 2, call 3, call 4, and we have target. Okay, so this is basically how this data, no, I'm drawing so well. So this part, this 4 is what is called data, in our data set, and this is what is called target. So this target is about three different classes, like 1, 0, 2, 1, or 0, 1, 2, three classes. So this is basically the table we want to obtain from this data. But now we have to kind of do some data engineering to obtain a tabular form of this data. Let's get back to work. Okay, so the steps in my website is also clear. So iris.data, so we are in step 2. We need to slice this data now. So if I say iris.data, we see that it's mixed up. So iris.data is mixed up. The 4 columns are mixed up. So we want to separate them, right? So we say iris.data 0 gives us this column, iris.data 1, iris.data 2, and iris.data 3. So we can actually slice this data, cutting up different columns separately. And that's exactly what I'm going to do. So if I say iris.data and slice off, to slice, you simply specify using a colon, comma, and then specify the column you want, column 0. And this gives us column 0. So if I run it now, you can see that it gives us column 0. This is actually a column, but it's actually arranging it in a matrix form. But it's simply just one column of this data of about 150 records. Okay, so I'm extracting the column 0 and putting it in a variable called column 0 is equal to. So this is my column 0. And I'm going to extract the 4 remaining columns from the data. So I'm going to paste this into 4 times. Just paste this right here. And this is going to be column 1, this is going to be column 2, and this is going to be column 3. So if I go back here, you can see that we actually are separating or slicing out different columns of this data out from the original data set. Again, this is what I have here in my website. Now, to create a dictionary from this data set, there's also a 4th column, which is this one, target, and I'm going to kind of also add it in a 4th column or a 5th column, and it's quite easy. In this case, I'm not slicing because the target is already in a different column called target. So I'm going to simply say target is equal to iris.target. I think that should be it. Target is equal to iris.target, which represents this last column right here. Okay, I think it's clear. And if not, please leave me a comment. Let me know what problems you might be having. Now we have our data set like this as 4 different or 5 different columns. How do we now combine them into a table? Okay, to combine them into a table, that takes us to the next topic, which is create a dictionary from a data set. Now, to create a table from series of columns that are separated, you simply have to create a dictionary like this. Let me just show you. So we have call 1, call 2, call 3, call 4, and target. And this is our dictionary. Now you have to say column. You have to say column here, column, 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 and after the column, you want to specify the data you want to use. So this is going to be the list of data, or the list of data that belong to that column. Okay, so basically you want to specify all this data here, you want to specify them as a list here. Okay, so we have to create a dictionary, and this is the format or the structure of a dictionary in Python. Okay, so let's go to do it now. So this is where we are create a dictionary. I'm going to call this dictionary a name. I'm going to call it Iris Dict. That's the name of this dictionary. That's simply a variable name. Of course, you know what a variable name is. And I'm going to start a dictionary like this. Now, the names of these columns are not call 1. Sorry, I think we made a mistake here. So this is going to be call 1, call 2, call 3 here, and target. So the column names of the dictionary, and these are the column names, which is what we have here, okay? And this is the data, this at this side is the data that belongs to those columns, which is the data that belongs here. For clarity, I'm going to simply use the names column 1, column 2, column 3, and column 4, and then I'm going to change it to the real names of the columns later on. So let's give the name call 1, okay, and then comma, call 2, comma, call 3, comma, call 4, call 3. I think it should be 0 to 3. Okay, so I'm going to change this to 0, and this is 1, this is 2, and this is 3. And finally, we have the last one, which is called target. Okay. All right. So at this side of the column, we want to now specify the data. Remember, the data, we've sliced off the data right here. So we have the data in slices right here, and we want to just put it right here. So in this case, we have call 0, that's the data. The text in quotes is the header of the table, because a dictionary corresponds to a table. The key, this, which is this side, corresponds to the header of the table, and these are the values, which are lists of items. This is going to be called, sorry, I think I just mixed up. So the comma is going to be on this side. Let me just move this. Just move. Okay, perfect. So this is going to be call 2, and this is going to be call 3, and here we now have targets. So we have our dictionary created now. Let me just run this code. Shift and enter runs it, and it says call 0 is not defined, because I need to run this as well and run this. So of course you can also click on this button here to run the cell. Okay, so the dictionary is quite okay, but how do we now display this dictionary as a table? How do we transfer this dictionary right here onto this table? And that's where we need Pandas. Pandas is also another module that you must use as a data scientist to analyze or to visualize your data, or to perform every other kind of analytics. So I'm going to import Pandas as PD. Okay, so I'm going to import Pandas as PD, and this is where we are in part 4. So I'm going to create a data frame. Now Pandas works with a data frame. Now you need to understand that when we import our data, this here is an array, this Iris Dict is a dictionary, and now we need a data frame. These are 3 different things holding the same data. For you to analyze data in Python, that data has to be in a data frame. It doesn't have to be an array or a list or a dictionary, but it has to be a data frame. And to get it into a data frame, you need to convert it to a dictionary first, and then to a data frame. So to create a data frame from this data, I'm going to say Iris df, let me call this data frame df, is equal to pd.dataframe. That's the syntax to use Pandas to create a data frame. And then give it the data should be Iris Dict, the dictionary. Okay. So I'm giving it the dictionary, and if I run this code now, this should be fine. Now, how do we know, or how do we see this data frame? So I'm going to just say Iris df, and it's going to show us the data frame that we've created, and you can see our data frame. Okay. But now you can see that the data frame has names call 1, call 2, call 3, and call 4. these names are actually not the real names of these columns. The real names of these columns, for instance, if you go to Google and say Iris Datasets column names, you'll see that the names are actually, let me just say, yeah. So you can see the names here: sepal length, sepal width, sepal petal length, and petal width. And these names are also provided in the Iris dataset. So let me just show you. For instance, if I maybe insert a row below here and I say Iris dot target names, we'll see that the names, oh sorry, so this is not the Iris dot target names. Sorry, that's my mistake. So the names are provided in, okay, I put them here in my website. Give me 1 second. Yes, sorry. Yeah, sorry, I'm kind of mixing up things a little bit. So what I'm trying to say is we want to replace these columns with the real names of those columns. Okay, so let's go back here and say Iris dataset column names. So let's use the real names of these columns. So I'm going to come here. I'm going to simply copy the real names of these columns and let's use it for the table. Okay, so I'm going to, because we are going to replace this call 0, call 1, call 2, call 3. Target remains target. So I'm going to just change here to uppercase and I'm going to insert a row above here. And let's use the names here. So it has to be sepal length. Let me just type it out. All right, so this is what we expect to have. So I'm going to run it again. So let's see. Sorry, this. Okay, so this is exactly how the table should look like. This is our table now. Let's now move on to part 5, which is replace the numerical values with text target names. What does this mean? It means that once you have this target, you have 0, 1, 2. This 0, 1, 2 you see here, of course you don't see 1, but there's 1 there, corresponds to actual names of the classes of petals. Actually, the data set is about a flower that has a sepal length. You can measure the length, the width of the length of the sepal, the width of the sepal, the length of the petal, and the width of the petal. Based on this length, you can now determine the class of flower it belongs. So there are 3 classes of the flowers. We have Iris setosa, versicolor, and begineer. So these are the 3. And based on the length measured of the sepal width, sepal length, and petal width, you can now assign a target class, or a target group of flower where it belongs. But we have target 0, 1, 2, 3, 4 does not actually tell us anything much, okay? So we want to replace it with target names. And what is target names? And let me just put the target names in a variable called the target is equal to iris dot target names. Remember, these target names are available in the data set, right? So I already said it before. So we have the target now, have the target names available, which is a list of 3 different items. So basically, 0 corresponds to setosa or setosa, and versicolor is should be 1, and begineer is 2, if I'm not mistaken. So how do we replace this 0 with setosa, replace 1 with versicolor, and replace 2 with begineer? That is what we want to do in step 5, that says replace numerical values with target names. Sometimes in data analytics, you have to replace numerical values with actual texts, and some other times in data analytics, for instance, when you have to do something like logistic regression, you have to replace text with actual values or with numerical values. In this case, we are replacing numerical values with text. Now I'm going to just write part of it and then copy from my website, because this will be a waste of time. But I'm going to explain this code, this piece of code to you. So to replace 0, anywhere target is 0, anywhere the column target is 0, we want to replace it with setosa. So to do that, I'm going to simply say, I'm going to alter the data frame, simply say Iris df. I'm altering the data frame .location or .log and specify the column we want to alter. The column we want to alter is Iris df. The column we want to alter is targets. Okay, and 1 second, yeah. We are going to set it where the target is equal to 0, if I can remember perfectly well. Where the target is equal to 0, and we are going to replace targets with equal to targets. Sorry if this is a bit confusing for you, but I think I should explain it a little bit more now. So what are we doing here? We are saying that we are manipulating this data frame, this Iris df data frame. We are saying that in the column where the target is equal to, where the value is equal to 0, and this is a column, we are going to set the value to target 0, which is setosa, because this is target 0 is setosa, target 1, target 2, right? Because this is a target. Target is 3 items, target 0, target 1, and target 2, a list of 3 items. Alright, so if I run this code and if I say Iris df, let me just show you another thing. So if you want to select just a few items from there, you can just say Iris df.head and specify, maybe just .head is fine. It's going to select only 5 items from there, okay? Now you see that it selects 5 items, and now instead of 0 we have setosa, and but if I say iris.head, second iris.tail, Iris df.tail, you'll see that it also contains values, which is like 2, right? So we only replace for where it is 0. We need to replace for 1 and 2. So I'm going to copy this and paste it twice, like this. So in this case, I'm going to replace for 1, it's going to be target 1, which is Virginica, I think, or versicolor. Versicolor is 1, and Virginica is 2, which is right here. So if I run this code right now, it's going to replace all the numerical values of the target. It's going to replace all of them with actual names of these classes. So I'm going to execute this by pressing Shift Enter on my keyboard. It's going to execute, and if I go execute this and execute this, I can see that it is now correct. Right, so how do we export this data set that we now have, we got from Python? How do we export it to a CSV so that we can use it in other places, or you can use it, open it in an Excel application and stuff like that? Alright, so one single line is going to help you to export. So let me just reduce the size of this one, and then insert one row below here, insert row below. Alright, so one single line is going to do the work. So I'm going to say Iris df. Maybe I'm going to just increase this a little bit. Iris df dot to underscore CSV, and specify the name you want to use. So it's going to be Iris CSV dot CSV. So the name you can choose for yourself. So if I run this cell now, it have exported it. How do we know? If I go back to this folder, you can see we have it right here. And if I also go to my file system, this is it. But if I go to my file system, this is a Prima1 folder, which we are working with, and you can see it's created now. 1236, date modified, today is 12, now it's 1236. So it was created right now when I run this code. To check the dimension of your data set, the dimension of the data set is simply the number of rows and the number of columns. So you simply say iris df.shape, iris df.shape. I'm going to run it and it tells us 150 rows by 5 columns. So check the data types now, which is number 8. You are going to say iris df.d types, and it tells us the types of data there. So floating point numbers, and then an object, maybe a string, which is of course is a string. Alright, so the object here means is a string, so you can't use it to work. So sometimes we convert to string, sometimes we convert back to numerical value. Alright, to build a summary of the data like mean, mode, median, and so on, we can now use describe. So if I say iris df dot describe, and it gives us the summary of our data set, and in this case it tells us the count, the mean, the standard deviation, the max, the quartiles, which is the median, the lower median, the upper median. I explained quartile before now, so check the description of this video. You see a link to where you understand quartile, an interquartile range calculation, which is very easy and interesting as well. Alright, so now to set the precision, you can use you can import set option and then specify the precision to be 2 or 3. So if I change the precision, let me just copy and paste. If I change the precision to maybe 3, so if I say precision is 3 or 4, and you can see, you can see that the precision changes now to 4 decimal places. You can see all the zeros added here. Alright, let's now do something interesting. We want to check the class distribution of the data set. Class distribution, what does it mean? It means how many of these observations are assigned or mapped to different classes. For instance, we have the classes or the targets. Of course, target is what we call classes. So how many observations map to the classes? The classes are only 3. So, and we have 150 observations. How do they map to the classes? So let's check. Let me run the code and then I explain it to you. So I'm going to say iris df dot group by target, and I'm going to say that size. I'm going to run. Alright, so it says they are evenly mapped to the 3 classes. So 50 of the observation map to Sectosa, 50 belongs to Versicolor, and 50 to Virginica. So this is very, very well distributed data set. But if you see that some data sets you have, maybe they are unevenly mapped. Let's say 100 belong to Sectosa, and 1 or 2 belong to Versicolor, and maybe 40 belong to Virginica. It's not evenly mapped, and that is why we say you have to check your class distribution, because if they are highly not unevenly distributed, you have to question the data set, or maybe do a bit of data cleaning or data engineering in the data set. We are going to be talking about this a little later. Want to check the correlation between the features. What is correlation? If you've done some statistics before, you've heard of correlation and regression. It's, as the name implies, correlation between 1 or more or 2 or more variables. So in this case, we have our variables to be petal length, petal width, sepal length, and sepal width. How are they correlated? For instance, it may be that the sepal length is increasing as the petal length is increasing. Or maybe that the petal length is decreasing as the petal width is increasing. So we want to see how are they correlated, and that helps you to give you some insights, so that when you see a high petal length, then you expect to see also a high sepal length, So in this case, if you have an idea of the correlation, if you see an outlier or something that does not fit into that correlation you've calculated, you want to also question your data. And this is what we call correlation. So I'm going to calculate the correlation, and place the result in a variable called correlations. So I'm going to create, do the correlation and place the correlation values in a variable called correlation. Iris df. So the function I'm going to use is called corr, C-O-R-R, and specify the method. So the method is Pearson. So Pearson is simply a method to calculate correlation coefficients of a given data set. So I'm going to print out the correlations. I'm going to run this. All right, so what does these values mean? You see that this value is simply like, it's like a matrix of the 4 features of the data set. The diagonals gives you the correlation between the same feature or the same column. So in this case, separ length to separ length has correlation of 1, meaning that it is the very same. So it's exactly the same. Correlation of 1 means the same. Alright, so what's the relationship between separ width and separ length? The correlation coefficient is minus 0.1176. That means a negative correlation, meaning that one is increasing as the other one is decreasing, or one is decreasing as the other one is increasing. That's a negative correlation here. What's the relationship between the petal width and the petal length? The petal width and the petal length. So they are increasing together. So the positive correlation, meaning that they are about the same. So one is increasing, the other one is increasing, and their values are similar. So that's basically what correlation tells you. So you can actually choose 2 variables in your data set and check the correlation between these variables, and it's also very interesting. Another thing you want to know about data set is something called skewness. Now the skewness of the data has to do with the distribution of this data. That brings us to a term called normal distribution or Gaussian distribution. Once you obtain a data set randomly, maybe you measure the students in a class, or you measure the ages of people you meet on the street, you expect that the ages be random. You don't expect that you measure 100 people and 90 of them have age between 0 and 5. That will not make sense. It means that the city is just filled with infants or toddlers. That does not make sense. If you measure randomly, you expect to get random measurements of different people, and many of them, the measurement should be around the mean. And that's measure. These values of a data set that is like this, that has measures that are distributed around the mean, is called Gaussian distribution or normal distribution, and that's what we expect in real life. If it is not like that, but the data is skewed to some direction, maybe you have plenty of particular measurements, it means it is skewed and it's no longer normal distribution. So what we are saying is that the normal distribution is like this. Let me just show you. It's like this. I'm sure you've seen this a number of times. So you have the median or the mean, and majority of the data you collect will be centered around the median. A few of them will be toddlers because if you are measuring the age of people you meet, a few of them will be like 1 year or 6 months, just a few. But many of them will be aged between maybe 10 to 50 or thereabout. A few of them, very few, maybe 90 or 80, and those few are what we have at these extremes. And this is exactly what is expected. It's a Gaussian distribution. But if it's not like that and it's skewed to somewhere, maybe this curve becomes like this, it means that we now have skew, the data is skewed. And that is what we don't want. If you have a skewed data set, you also want to question it, or you want to do some kind of data cleaning or data engineering to clean up this data set. So to check the skewness of your data set, I'm going to say iris df.skew. And if I run this, you can see it gives us the skew for each of the observations or each of the measurements here. A positive skew means that more or less a few of them are above the mean. Negative, a few centered at the other direction. But now these values are quite small. So in as much as there's a skew, the skew values are quite small. So this is how we come to the end of this primer one to help you check if you are ready to do some data science. We've done primer one, but we also have primer two. Primer two has to do with visualization, as I've showed you before. But at this point, I want to say if you are ready for data science, then join the other data science channel which I created, Kineton the Genius. In 5 days, we are going to be starting data science in 40 days, which means 20 minutes every day. And we are going to be covering both theoretical but mainly practical data science. We are going to be solving real problems in data science in 40 days. However, before then, we are going to do primer 2, which has to do with data visualization. We're going to do different kinds of plots, histogram, density plots, scatter matrix, and a whole lot of things. So you also have a bit of knowledge of data visualization, so that you also will have to decide whether you can do some data science, because data science requires a bit more effort, a bit more analytical way of thinking than normal software engineering. So that's why in this channel I do software engineering, building applications, Java, JavaScript, Spring Boot. But in the other one, I do Python, data analytics, MATLAB, and all these other ones. So please, if you are ready for data science, join that channel or subscribe to that channel, and also subscribe to this one if you are a software engineer like me, because if there's something you need me to know, you want me to improve on something, please, I want you to leave a comment for me below. I remain Kineton the Tech Pro, and I'm always there for you.